Alright, so today for our warm-up, I need 3 people that are going to visually just show something. This is pretty simple. So I need 3 people to volunteer. Alright, tomorrow you go to the back for me, Rick, you go to the back, and Ray.
What am I doing? Wait, what am I doing?
Just go to the back. Guys, have your folder out so you can be following along with us. Alright, Cohen. I'm going to be marking you down because you're just talking out in the middle of class. If you don't have a pencil, you're supposed to come to class with the pencil ready. I'll give you one, but I'm still going to be marking because now I'm stopping class so you can get your pencil ready about 7 minutes after we started. Okay. We today are going to work on how we can analyze and sketch these graphs. The first one, what you're going to notice is on this graph that we are going to make, my x-axis is in time, and my y-axis is the distance from the back wall. Big thing that's different is we do not have a scale. So what we're doing today, we're not going to have scales. We're just going to kind of be showing what happens. Now, what kind of correlation do you think, going back to our last lesson, no, let's get this stuff out, not just drawing pictures. What would be our correlation? What do you think would happen as I ask someone to walk from the back wall? How is the distance from the back wall going to relate to time? Is it going to be a positive correlation, a negative correlation, or no correlation at all?
Negative.
Nope. It's going to be positive. Obviously, as I start the time, as time goes on and gets bigger, and they're walking, they're going to get farther away from the wall. So we should have a positive correlation happening. So the first one that we are going to do, Braden's going to do this. I am going to graph what Braden's going to do. Braden, all it says you have to do is I need you to walk slowly to the front wall at a constant pace. Yep. Go, Brady, go. Move so she can go. Go ahead. Alright, so. No. Good. Maybe stop here. Now, when I graph this, she started at 0 and at the back of the wall. And when I said to start, she's able to move at a constant pace. Now, we use a straight line because her walking pace stayed the same. Consistent. The slope was the same, the steepness. Okay, Ricky, you're going to do this, and I'm going to do yours in green. But this time, Ricky, you're going to move at a quicker pace. You're going to walk faster than she did. Okay? Alright, go ahead. Now, when I draw his pace the whole time stayed the same. It'll be straight line. How's it going to differ from Braden's?
Because I was slow.
Huh? What do you mean the top's going to go down? The time? Okay, maybe. But I didn't have an ending point. How am I going to draw it, though?
It's going to be a hexagon.
It's going to be higher to it. No.
It's going to be
shorter. It's going to go from here and then
Well,
it's going to go down.
I'm not having an ending point.
It's going to go below the
I'm not having an ending point. I'm just saying the distance from the wall to the time. How will I graph that compared to Braden's? Is it going to be the same line?
No.
It'll start on the same one here.
Start the same place.
And then it's going to be...
It's going to what? It's going to be...
Going to be lower because the time went down.
Yeah.
But let's talk about this. Now, some people are going to think it's going to be less time, but the x-axis is time. The y is place. Let's pretend this was the end of the wall. If this is the front of the wall, it's going to take Ricky less time. It took him to here, where it's going to take Braden probably all the way to here. So it would have taken Braden longer. The last one we're going to do. The last one we're going to do is Jamari. Jamari, when I say go, you're going to stand at the back room and not move. Go.
Oh my god, this is wonderful.
And he's doing a good job so far.
You won't. I saw him.
Go,
Jamari, you blinked. He's chewing his
All
lip.
right. Now,
Get money.
how would I graph his?
Oh, it would
You
be
don't.
a
You
straight
don't.
line.
Oh,
Just be a straight.
The straight line.
straight line where?
Oh,
On the bottom, on the X.
On the top.
On the X. His distance.
Didn't go anywhere.
Oh man, I thought that was on. His distance. Oh, there's so many people talking. Boys and girls, you need to have your voice off so we can get through all this. But, oh. This one. Alright, you three can have a seat. I'll get you a sucker.
What? They got to walk and they get a sucker.
Brady lost like 10 calories before she can gain 20 back.
2 minutes now. Next. Oh.
Nobody likes it.
Alright, now the next part. Oh, I might have to stop giving Andrew voice off so you can follow up. The next one, I'm going to see if someone can do this one. You're going to go to the back wall and you're going to model what I'm going to draw. Now, you can't do this until I draw this. And if we're shouting out, we're going to be down with suckers for the rest of the class. Otherwise, I have a bunch to be giving out. So, what I want to draw is you're going to start at the same place, and we're going to compare it to Brady. So your walking pace is going to be compared to how Brady walked to the front at that slow pace. So do not shout this out. But I'm going to start there. Not talking out yet. Not talking out means you're not. Nope. Not talking out means you're not saying anything. I want to see if you can look at this. We're looking at the orange one. Why did my orange heart go away? Oh.
I think I know. I don't want to walk.
Okay, without talking.
I can get it up.
Alright, Michael. Can you go to the back and can you model this? If people are continuing to interrupt, I'm going to be marking your planners because we're already starting to fall behind the schedule now. Alright, you ready, Michael? You can begin. Good. Oh, you take it. Took my last class a while. Now, if we look at his, he first increased at a constant line, constant rate. When it's a straight line, that's going to tell us it's a constant. Why did he stop and just stand still? Cohen? Good. Here, we see time as passing on, but my distance didn't move. So he stopped. When this went down, my last class, they started turning and walking other places around the room. So one person ended up over here. And I was like, what? And then someone's like, oh, what's wrong? And they tried it. Why did you go backwards? Why did Michael step backwards on this, Tyler?
Because your distance goes backwards.
Good. Since this decreased and it went down, we decreased. Now there's one thing I wish he would have done different. The last one, it increased. And so he went back forward again. But what do you notice about the increase? It was pretty steep, right?
Yeah.
So what should... Exactly. You should have started running. Because this one, this slope, he was walking at a kind of a quicker pace than Braden's. Braden's pace is the blue. So he went faster than her. He went faster than Ricky's. So he should have walked fast. Then he stopped. Then he went backwards. And then since someone went straight up almost, he should have sprinted. That last pace would have been fast. That is how we are analyzing our graph. The steepness of the line is going to tell us how quick we are doing things. So this is also going to be worth 3 suckers, even though there's 4 of them. Open up your notebooks, your foldables, because it's in here, so you have to have it in here for me to award you. But I'm going to pause this, and you're just going to talk quietly. If you're loud, you will not get chosen. But you're going to work with someone next to you. It says each graph shows you your speed on a bike ride. So the y-axis is your speed. How fast are you going? When it goes up, you are going faster. Your x-axis is the time. When you go to the right, it goes longer. There's 4 scenarios. I'm going to read through them, and then you need to decide which one of these graphs match up. So you increase your speed, then you ride at a constant speed along a bike path. You then slow down until you reach your friend's house. You ride at a constant speed, then go up a hill. Once on the hill, you increase your speed. You increase your speed, then go down a hill, then you quickly come at a stop at an intersection. And you increase your speed, then stop at a store for a couple minutes. Then you continue to ride, increasing your speed. Probably because you grab yourself a Red Bull or something.
Yeah.
Got all sugar high. Okay. Okay, let's see what we can come up with.
So I'm not done yet.
It's alright. It might help you as we go. First story problem. Now, when you guys went to solve these, there's actually a couple ways we could always do this. One, you could have looked at the graph first for A and just said, okay, I started here, so I'm not moving. And then you could have just grabbed what was happening and tried to match it up. Or you could have read the story problem and just matched up with what happened. So let's see, I'll have someone first tell me the answer and then we'll discuss it. So, for the first one. Alright, Alejandro, what did you put? Okay, so you said C. Here is how I would have looked at this. You increase your speed. Okay, so I would say it's going to be like that. It's going to have to be a slope that's positive. Then I'd ride at a constant speed. Okay, so it would be a horizontal line. Then I slow down until I reach my friend's house. Uh-oh, now it's just even worse the more I do that. Slow down, and it stopped. If I take those 3 pieces and I put them together, should it look like something like that I look for? If I look at C, I started at 0, increased, constant, slowed down, and when I see I stopped, I'm all the way to the bottom because speed is at 0. That means I'm not moving. C is correct. Ooh, that's correct. Is correct. Second one. You ride at a constant speed. Am I starting at 0?
Yeah.
No. So that really should give us one right. Okay. I'm riding at a constant speed. I'm going to go up a hill. So I'm riding at a constant speed. Well, I can't get this out. I need the answer first. Nathaniel, you're sitting nice and quiet. Okay, you said B. So, constant speed, horizontal. If I go up a hill, what do you think is going to happen to my speed?
Down.
You're going to slow down.
When I get to the top of the hill, yeah, like when I get a big hill, it's going to go down, and it's probably going to go up pretty fast. So now I'm looking for something probably like boom, boom, boom. If I look, B, constant, decrease, increase. B was correct. Third one. Bryce. Okay, I increase my speed. I go down a hill, which is going to make me go even faster, more steep. Then I quickly come to a stop. Ooh, so I'm going to come to a stop, and it's going to be pretty quick, so probably pretty steep. If I put them together, there, more steep, boom. Should be A, it's correct. Constant increase. I went down a hill, so I'd go faster, so it's more steep. And then I quickly stopped, probably because it's going down the hill, there's a car, and I was like, I'm going to die. A.
I ran into a car once.
It is correct. That explains a lot.
The last answer is D.
Can I
Why?
One. Do I get a sucker?
Absolutely, if you can answer my next question.
I answered it.
D is correct, but I'm not going to go with that. I'm going to pause again. This one's going to be short because it's taking you guys a while at the beginning, so like I said, that affects how many questions we can over. I'm going to pause this. Work with a partner so you can talk quietly to the people around you. What is happening in this graph? I'm going to point out something I didn't to all the other classes so afterwards, but I want everyone to focus on this. A couple of big things. One, I noticed it says height and time. So the things that I'm noticing is every time whatever's happening goes to the same height.
And it stops.
Well, it's not stopping.
It's slowed down.
So then, how do I know it's not stopping?
Oh, I know it.
It's uphill, downhill.
You're a sucker.
It doesn't have a straight line.
And not a straight line. These are curvy. This is gradual change. And our points where they stop and change directions are not vertices. They're not points that directionally change. They round it. The other big thing is the distance between looks to be the exact same on each one. So I'm going to pause, give you about 30 seconds.
Wait, what's the question?
You need to be able to tell me what do you think is happening. So here's what I'm going to do. I'm going to listen to a couple people's. Like I said, there's not just one right answer, but there's a lot of wrong answers. And that's what we have to think about the analyzing. I'm going to tell you why it'd be wrong. Because some of you have really good ideas, but when we're analyzing, there's reasons why it's wrong. So, Cohen, I'm going to listen to yours first.
Okay. No.
Okay.
My idea was it could be a heartbeat.
Okay, so Brayden wants some of this credit, so she gets the incorrect answer as well. Could not be a heartbeat right now.
Oh, why?
Why?
Because heartbeats are inconsistent.
Well, and I could have usually a heartbeat would change.
They don't go.
You're right. Heartbeat, you're right. My heartbeat could be a steady heartbeat, which that actually when you first, I was like, oh, that's good. But if we think about our heartbeat, they're usually boom,
Well, it was my idea.
boom. I don't do my heartbeat and it's like, boom. It doesn't, it's beat, beat.
You got that problem.
It's compressing.
Wait, I have another idea.
If all of a sudden your heart, when it goes to pump, it goes, yeah, it kind of does it. Your heart,
Do we just
so
have
look,
stop?
ugh.
You got a
So,
problem.
We
heartbeat,
need to-
not a bad idea.
Sucker.
But probably no. We'll see.
Alright, so if someone's biking and then they go up the hill.
Listen to this.
Well, someone's biking and then they go down the hill and then they go up the hill, but then turn around and they go back up.
Okay. So maybe a person's going up and down the same hill. Okay. The only reason I would reject that, my other class did the same thing. There you go. The slope going up is about the same as it going down. Am I going to go up a hill as fast as I'm going down the hill?
No.
No. So we probably reject that.
Oh,
What do you mean?
Sound wave.
Oh, I was just gonna say that.
wait.
I
This,
swear to God, I was gonna say sound wave.
this is
sound wave.
On everything I love.
I don't care that. It's wrong. I'm telling you.
Yeah, I'm gonna call my mom
Wait.
right now. You can't take that.
We still have a lot of side conversations. This is probably more of a consistent, like a sound wave. Or it could be like a visual wave, a light wave that we're not seeing. But the waves, the reason is they're not pitched. But we're talking about, you guys have to learn this later, we do this in science, about wavelength, amplitude, the crest, the trough. That's what all this is. So when it stays the same, if I turned it up, that would change the wavelength or even how the amplitude would be. So this is probably a consistent sound wave. Alright. Yeah.
Just my idea.
The mumble at the end where you're
No,
oh,
it can be that. It can be going up and down to
It's
same
the
right.
same.
It's the same. It's the same going up and down an escalator. It's the same right back.
The only thing is on the escalator, if we thought about it, I'd go up, but then I'd have to stop, get off, walk across, and then go back down.
No, it's stairs. Somebody working out and they're going upstairs.
Yeah, you
But
can
then
go
we still
space
say we
behind.
probably wouldn't go the same speed.
Yeah, you
You
would.
go fast. If you run up the stairs,
You're
you
gonna
go to the
ride.
stadium, and you run up and down the stairs, and you go down, you run down faster. You get tired, you wouldn't keep that steady pace.
That's if they want to. They don't have to run down
Yeah.
fast.
I said
Alright,
cycling.
let's move forward because I still have two other examples that we're going to throw suckers out at them. So,
my hand
key concept.
I've never been called on.
Because you guys are being loud and interrupting.
Ooh, quiet.
Alright, so key concept for today. Key concept for today is Cohen. This is why right now. Okay, what I'm needing you to understand is when we look at a graph and we show the comparison between two quantities without specific numbers on the axis, that's why we don't have a scale. But, big thing we're going to learn, when our slope is increasing, it's showing an increase in relationship between the two axes. The more steep it is, the more of a change. If it's more gradual, it's going to be more flat. So increasing is our positive slope. This is important. If I have a horizontal line, I have no change. It is constant, but it is no change on the y-axis. Is it changing on the x-axis? Yeah, this one's time. Just because the distance, if I was running and I stop and I start taking a breather here and I'm just standing, time's going on. I don't stop time.
What if you're Doctor Strange?
Unless you're Doctor
I've
Strange.
seen that movie.
So, that
Why? Stop talking. Yeah, shut up.
again. And then our last one, when it's decreasing, that's showing our negative correlation. So, I'm going to skip this one for right now, and I'm going to go right to our last two examples. This is in your foldable. This is one that's going to be for sucker for the person that does it right. Somehow we messed up on your foldable. We have the same one twice. So it's on your purple and your blue sheet. You only have to do it on one of them. But this one, this is like what you're going to do for your homework. It says, a stopped subway. So it's stopped. You're going to start here. Gain speed at a constant rate until it reaches maximum speed. Brady, quit talking. So a stopped subway train gains speed at a constant rate until it reaches maximum speed. Once it hits maximum speed, it travels at this speed for a while and then slows down at a constant rate until it comes to a stop. So this is the one for the sucker. Draw in your notebook, your foldable, how would we graph this and model it?
Did you write down that?
Did I what?
Write down that I do my homework.
I'm so
For
good.
today?
Yeah.
No, I don't have you for anything yet.
I'll show you. But you need. I'll show you. You did 7.1.
Oh, look at that. Alright, Lee, come on up. Can you do this?
Yeah, I
I
can.
think I can. You can't.
Alright.
Like that.
That would be that. So,
Yeah, I had it
I
right.
totally did that.
so a train, it was stopped. We increased, hit the max speed, traveled there, and then went down until I stopped again.
Max speed?
The max speed, so I mean, if you wanted to draw all the way to the top, that's okay.
That's what I did.
That's fine. Okay, last one. This one, there is a trick in it. So be careful. Says, a fully charged battery loses its charge at a constant rate until it has no charge left. Now, we are going to pretend we plug it in right away. So as soon as it dies, we plug it in. You plug it in, and it fully recharges at a constant rate. As soon as it's fully charged, it turns on, and it starts losing its charge at a constant rate till it is dead again. How would you graph that?
Ow.
Alright, Andrew.
You looked right at me just to that.
Yeah, but you keep talking out.
That's
How many times is it going?
So a fully charged battery loses its charge.
Alright, and then it does it again.
Huh?
It does it again like one time, right? Not for us. Why didn't you use that one taller? You're supposed to be 6 eyes.
He has a mistake.
Oh, I know it. I know it. And
So-
But you're supposed to break in the middle.
I got it.
Because
No,
you
I
already
I
did.
got it.
No break, because I said we did. Right away.
said I'm fine.
I promise you.
Because it's fully.
I know. Hey, it starts from the top.
Yeah,
You gotta start from the top. And then
Why do we have to start at the top?
I had to start fully charged.
It's already
It
fully
makes an
charged.
N.
That's not top. That's inaccurate.
So,
It's inaccurate?
let's see. Fully charged, loses its charge all the way at the end. It died, we plugged it in. I don't know, did he go all the way back?
Oh my
and
god.
No.
You know what I'm doing.
I plugged it in, it's really charged, and then it loses charge to the end. Okay, for effort. Alright,
I deserve one for effort.
your assignment
What?
for tomorrow. Pay attention so you understand this part. Guys, I only have a couple things left to say, then we're done. Your assignment. If you look at this, I have this picture right here. You have the picture on the right. They have an A, B, C, and D. I have 6, 7, 8, and 9. Riley, sit up so Cohen can go sit so I can finish going over homework. On 6, 7, 8, and 9, you're going to read this and say, you run at a constant speed. On this graph, which one, A, B, C, and D, would represent that? And you put the letter down. On 7, you slow down at a constant rate. Which one would that be? I'm about to have you later. 10, 11, and 12, you are going to have to write in words. Describe what is happening here. I want you to tell me what happened in the picture. Then, on the side, 18 and 19, you need to do what we just did on the last two examples. They give you 18 a situation, 19 a situation, and you have grid to graph it. So 18's here, 19's there. That is your homework due for tomorrow.